Okay, good stuff. Hello, everybody. I'm Matt Houghton. I'm an AWS Ambassador and Community Builder. I also do have a day job, and that's as an architect at a company called CDL. We're based just down the road in Stockport. We're an insurtech, and we're focused on the use of data and AI to power digital insurance journeys. I suppose like a lot of people here today, GenAI, I would guess, has become like a standard part of building out features in software. Who's using an AI coding assistant today, for example? Yeah, a few hands going up. Who kind of uses things like ChatGPT, Copilot to ask questions in natural language? A few more hands go up. You can see where this is going. But to me, I work for a software company, and to us, the kind of real benefit of generative AI is actually delivering new features that are powered by AI. Who has features that they've written in their software in production today that are actually powered by AI? Less hands go up. That's very normal. So there's a lot of hype, less actually in production. So it's that last part that I want to focus on today. So the talk's going to highlight kind of risks around GenAI workloads, cover strategies for testing and securing those workloads, mainly on the AWS cloud, which is where I work, and in particular using the Amazon Bedrock service. So let's dive into some of those risks. The foundation of any successful AI is to have like high quality data. I don't keep it on. I'm tapping the laptop. Tap to cancel. Would I like to keep the energy saving countdown? No, I don't. Thank you. There we go. always read the manual. Suppose, yeah. We were talking about risks in AI and data. So often I found that it's really tempting to jump into what I see as these trendy new features in AI components that get bandied about. There's a lot of hype about them, but there's less, emphasis on checking that the data that it relies on is actually sound, because that's less interesting, I suppose. Another risk that I've seen is what I call ingesting the world and building an AI monolith. So when it comes to that agent architecture, what I found through my testing is small is better. It's been more effective to build small, focused agents rather than a single large monolithic agent. That doesn't mean that agents can't be then choreographed to interact together to form a larger system overall. And working in DevOps, you're probably familiar with like this microservices type approach and the benefits that typically affords you. So improved modularity, it's easy to maintain, it's easy to test and debug. But on AI specifically, if you've got smaller individual agents, you also get the flexibility to use different foundational models for the specific tasks that each agent is for. This point can also tie up with misinformation. So given a broad ingest of information from, say, like a company SharePoint site or intranet, it's actually very easy to spread misinformation, either maliciously, but more often than not, it's just by accident. So who's got like a company intranet here? SharePoint, Wiki, that sort of thing. Yeah, a few people. Would you say it's always kept up to date with the latest information? Never is it? No. So if we just ingest all of that, the AI is going to answer based on that information that we know is out of date. So examples I've found is like people keeping old copies of company policies in, say, like an archive folder, which makes sense to a human. They know not to go looking in there for the answer. They know it's old, but to AI, it doesn't know that. So instead of ingesting the world and hoping for the best, it's better to focus on smaller, higher quality data sets with human oversight, and that helps you build trust. You've got to employ things like content moderation policies, fact-checking procedures, and collaboration with human experts to help prevent the spread and generation of misinformation. Also, with companies seem to be keen to be adopting AI or under pressure to adopt AI first, it's very tempting to jump in without defining what success looks like. So it's really important to set out some measurements for how effective your AI agents are going to be. It's essential to define specific evaluation criteria and track this performance over time. Okay, so we talked a bit about data, so let's look at how AI affects data engineering. I don't think it does that much. This diagram is actually from a talk that I got to co-present at reInvent back in 2023. But the architecture that you see here is all really relevant today, and AI doesn't change that. So in AI, like we've talked about, you're going to want to have good quality data. So you might be taking data from like online transaction processing systems. Maybe that's in DynamoDB, maybe it's in RDS, and you're going to want to do some sort of extract, transform, and load on that. Data engineers have been doing that for years. We might use a managed service like Qlik, but we're typically running Python or Spark, just like we have done for years. And you maybe want to take advantage of like data quality checking. So Qlik has data profiling, which can help you identify like missing values from columns, poorly distributed data. So in the world of data engineering, these skills and data ops, I suppose, are really, really valuable to actual AI workloads too. Also, once you've got your data, and let's assume it's in a good state by now and got the quality right, it's actually only useful if people or AI can actually access it. And this ideally needs to be in a frictionless way. And you've got to balance that, of course, with security and governance controls. So this is where a service like DataZone comes in. So this is a data management service that makes it faster and easier for customers to catalog their data and share and govern that across clouds, on-premise, third-party sources. What we're seeing is also AI helping us to do this. So within DataZone, for example, it uses generative AI to generate metadata. So describe our schema, generate business descriptions based on the technical name of columns and fields. So using generative AI itself can actually speed up things like data discovery and cataloging and improve data quality. So the two things can go hand in hand. So I'll do a quick demo now, or a pre-recorded demo, because I don't like the demo gods and the demo gods don't like me. So this kind of shows how you can start to use unstructured data. So we talked about columns there and fields, and that's traditional. You know, we're pretty good at managing that, but AI, of course, handles unstructured data as well. So what if you've got some of that? How can you start to turn that into useful information that can power your AI agents? So this is a feature within Bedrock called data automation. It streamlines the generation of valuable insights from unstructured data and multimodal content like images and things like that. So I'm basically just creating a project in here, and I'm going to upload some unstructured data, I suppose. So this is a receipt from some shopping that I'd done a while ago, and we're going to ask essentially generative AI with the context within this service to analyze this information and see what sense it can make of it. Make it go quicker because this was real. So it's done a summary. So it's said that I've bought some chips, some carrots, toad in the hole, and fruit gums. Colin caterpillars, if you're interested. They're my wife's favourite, so it does count as a date night. But you can see what the AI has done here. Like, as humans, we can very, very easily interpret that this is a data table as columns and rows. And the AI has done this for us. And because it knows it's a data table, it's given me that in CSV, it's given me it as a HTML table, it's given me it as a markdown table. And although this is a console, you can do this programmatically through the AWS APIs, and you can get access to all these elements programmatically. So you can include this sort of thing in your ETL pipelines. And we're just seeing like it's picking out the keywords here now. Some things to note: this is generative AI, so it's prone to hallucinations and getting things wrong. The first time I recorded this, it said that I'd bought straight cut cheese, for example, which is wrong. I didn't, but it had a guess because of what the shortened version of it there. But on the second run, given the exact same prompt, it came out with chips, and we'll come on to that next in testing. because this is what's known as non-deterministic. So this refers to an inherent challenge that we've got when we're dealing with generative AI, that the same input can produce different results and different outputs on repeated runs, even with the same prompt. And that makes it really difficult to reliably test and verify a system's behavior. So this is very different to normal software engineering and testing. If we're doing a unit test, 1 + 1, we assert that equals 2, and it comes out as true or false, and the unit test passes or fails. You can't do that with generative AI, because the answer it gives, given the same inputs, each time is different. So what do we do about that? It changes the testing methods. So the methods that rely on predictable outcomes, they're not going to work as well for generative AI. So this increases the value of human evaluation. So assessing the quality of GenAI outputs often is going to require subjective human judgment to determine if the response is appropriate. You can do things like statistical analysis, so you run multiple tests with the same input and analyse the distribution of outputs to understand the range of possible results. You're going to also want to have quality metrics that measure different aspects of the output, like coherence, accuracy, relevance, and bias. So an example of this, I work obviously in insurtech. When you read an insurance policy document, and I probably shouldn't say this, do you find them straightforward to read? So, for example, can I drive my car in France? Typically, that is not a yes or no answer. It's probably yes, but with certain conditions, like you must not drive over 500 miles while you're there. You may not stop in the European Union longer than 30 days. But technically the answer is yes. But the completeness of answer in that context is what you're really looking for, because you want to drive your car in France, but you also don't want to get caught out if you crash and you've been there 31 days and you're only allowed to stop 30 days. So we measure things like completeness of answer alongside correctness of answer. Got to have, and this is actually very difficult in terms of the amount of test data you need to generate. So you need data diversity as well. So you need a wide variety of input prompts to test your model's ability to handle different contexts and situations. Monitoring and feedback loops. You basically need to be able to monitor real-world scenarios and use the input prompts from real users to start refining things like your training data and improve the accuracy of your agents. But overall, you need to move to what I'd call intent-based testing. So your focus shifts towards evaluating whether the output aligns to the intended meaning or purpose of the prompt, rather than just checking for an exact match like you would do in a unit test. So we've got an architecture for how we do this at CDL. Again, we're using Bedrock as the key component in this architecture. So our process is basically, for testing a model, is first define a set of questions. So these are shown here as the prompts in an S3 bucket. So this is just a JSON lines file containing the question and expected answer, also known as our ground truth data. And then the tests, known as evaluations, we run those in a couple of different modes. First of all, we run automated evaluations, or LLM as a judge evaluations. So this is where we ask the LLM under test, to say Anthropic, to answer the question, and then we pass that along with our ground truth data and the response back from the first LLM to a second LLM, ideally from a different model family, so maybe one of the Amazon models or one of the Meta models. And we ask for the second LLM to check the output from the first LLM. So the second mode then we do is human evaluation. So we use exactly the same prompts, but this time we ask a team of people to evaluate the responses from the model. And under this mode, we've got basically a URL that gets generated. They get an email with some instructions, and they log in and they click through and they score the models. And you'll see a demo of that in a second. But all of these evaluation results, whether it's automated or human, they're stored in another S3 bucket, and we can do further analysis on those, like using Amazon Athena queries or something like that. So yeah, another recorded demo. So this is an automated LLM as a judge model. So this is DeepSeek. So we've fed this, I think, 25 questions based around insurance, and a sample of my fake policy represented as a JSON blob. And we've basically run an automated evaluation, and you can see all these different metrics. So talked about correctness, completeness of answer, and you can see all the scores against each metric, and then you can basically use that to help you assess whether that model is suitable based on your risk appetite. So as I said, here's my insurance policy represented as a JSON blob, and right at the bottom there'll be a question in there that the LLM has answered, and it's got a score. So you can dig into this. Overall has a lower correctness score than you would like. You can dig into why that might be based on the question. So the second one is how human evaluations work. So this is what people see when they get asked to take part in a human evaluation. So again, the same JSON payload, which represents my insurance policy. And the question is, what is my policy number? This is the response for from one LLM. That's the response from a different LLM. And there's my reference response. That's my ground truth data. So that's my business domain expert has put that as the answer into our prompt file. So basically, you can see both LLMs have got the answer right. This one has perhaps got a more complete answer. This one's to the point. But basically, what we're doing here is those same metrics, where it's fluent, where it's got coherence, whether there's any toxicity in those responses, we're actually asking our human experts to validate these on a Likert scale here. And the other thing to point out is you can give instructions, it accepts markdown format for your instructions, so that's quite easy to do. As you can see, this is a very slow process. So all this automation and GenAI potentially putting people out of jobs, what we're actually seeing is new jobs being created, people doing different jobs. So as you're a DevOps crowd, you'll want to not do that through the console. You'll want to do it in a CI/CD pipeline. So if you scan that blog post there, it'll take you to some code examples where basically I've done the automated LLM as a judge evaluations into a set of scripts, which you can include in your CI/CD pipelines. So far I've kind of focused on like the testing of the foundational models. So I'm going to touch on user experience testing or user testing. So we've found taking a human-centered approach when building out agents quite key. We found an intuitive user experience and well-tested features help users understand and trust the AI, especially when decisions are potentially complex or opaque. User testing validates that the AI features address actual user needs and behaviors appropriately in the real world. A smooth user experience encourages users to actually embrace and continue using more and more AI capabilities. User feedback we found to often surface edge cases, unintended behaviors, and ethical concerns, which might not be evident in controlled testing environments. Testing helps you, user testing has certainly helped us determine how much explanation or control users need over AI decisions. Again, crucial for usability and compliance and trust. Well-designed and tested AI features minimize confusion, reducing the need for kind of customer support. So you kind of automate something in one sense, but if the user experience is poor, you end up ringing the call center anyway, so there's no benefit. Basically, again, continuous UX feedback loops are going to help you refine things on a rapid basis and optimize the AI features based on real usage patterns. Another thing I've been working on recently with the team at CDL is assessing our existing tools, so things like login, monitoring, observability tools, to check that they actually support these new GenAI based features that we've got. So for this, we built a sample GenAI workload that was non-sensitive, so we could run it whenever we liked, and we basically then checked how our existing tools reacted. So I'll run through a demo of this, the sample workload, show the AWS native tooling, and then third-party options in the observability space for this. So this is the workload. It's basically Python, and all it does is it asks a series of questions based on the AWS well-architected framework, which I've got a knowledge base for, and imported all of the public PDFs of well-architected into that. So it's asking like general questions that a team would ask me as a human architect. And basically all I'm doing is going through all the different Bedrock endpoints, like invoking a guardrail, invoking a model, invoking a different LLM, invoking a model with a guardrail, invoking a guardrail independently, using the Converse API, basically all of the APIs that are available in Bedrock, I'm trying to hit all of those so that the observability tools get the chance to capture all of that telemetry. So you can see it running here, and this is Claude 3 Haiku at the time, is answering some questions. So that's all looking good. This is the AWS native tooling out of the box. Let's move this on a bit so we can see it. There we go. So it's been running for a little bit. So out of the box, you get a built-in Bedrock dashboard. So you can see the invocation count, you can see the latency, if the video wasn't too quick. You can see the input tokens, output tokens, counts by model. So kind of key things here is the input token, output token, and then the model name. Those are the three things you need on AWS to determine what the cost is. And then if it did have any errors or was throttled, fortunately that day I didn't get any throttles and didn't get any errors, but they would be in those dashboards. That's not something I've built. Again, this is just completely out of the box on AWS. So if you're using AWS native tooling and you want to get started with AI, this is just there and you can use it. So it's quite nice. And that was later on in the run. So you can see all the different models there and the tokens that they're consuming. Okay, so what if you're maybe not all in on AWS? So this is where Open LLMetry comes in. So have you heard of OpenTelemetry or OTel? Use different observability tools. So OpenTelemetry or OTel is pretty standard. This is based on OpenTelemetry, and it fills a gap basically between the OpenTelemetry SDK layer and then these new AI features. So this though has been adopted by most of the popular AI frameworks, so like OpenAI, Hugging Face, LangChain, and also different providers, so people like Datadog, New Relic, who's got a different observability tool? You're all quiet today. Well, we use Dynatrace at CDL, so that's a different one. So this shows that exact same workload, but instead of viewing it in CloudWatch, I'm actually viewing it in Dynatrace. So you can see here all these different bits that workload is doing, like invoking a model, asking a question using a knowledge base or using a RAG workflow, using the Converse API, applying a Bedrock guardrail. All these are being captured, all their response times, typical kind of like monitoring observability stuff, requests over time, failures, successes, percentiles, that sort of thing. So nothing new there. But out of the box, because I'm using Open LLMetry, you can see that Dynatrace has actually picked out that this is a generative AI type feature request. So I'm calling this API, and then that's called a different API under the hood. And it's picked out that this API returned a response, and there you can see it in the GenAI pane over here. And you can also see that there's like a 200 there. That's the one of the AI inference parameters, so like temperature, top P, that sort of thing. It picks all of those out and puts it automatically into your observability platform, as long as that supports OpenTelemetry. So no changes out of the box, that just worked. So that was really cool. Okay, guardrails. This is another feature in Bedrock where you can implement safeguards in your applications. What you do here is you create multiple guardrails tailored to different use cases and then apply them across different foundational models. So guardrails offer a safety protection on top of any native capability provided by the large language models. and you can use it for any of the large language models that are available in Bedrock, and including any fine-tuned models that you may create. A guardrail basically sits in between your application and the model, and it will automatically evaluate everything going into the model from the application and then going out of the model back to the application. And it's there to help you detect and prevent content that falls into kind of restricted categories, like this list that you see on the screen. Okay, so some demos of how this works. So again, a code level demo, and we'll do one in the console. So this is a piece of Python code that's going to create me a guardrail. So again, it's an insurance use case. So the use case here is I want to prevent a chatbot that's GenAI powered from discussing what I perceive as high risks in insurance. So things like credit history, crime, past claims, that sort of thing. Those are typically complex cases that we think are better handled by a specialized human agent. So we're basically creating the guardrail here. We've got some examples of things we want to deny, including like a word list, and then we've got some messaging on how we want to handle the response if it meets one of these guardrails. So the first thing is we create the guardrail, and in the console here you see we'll get an ID and a version number for that guardrail. So we will grab that and go to our next piece of code, which is basically just going to call a large language model and ask a question, but in our inference profile we've asked it to use a guardrail. So the question we're going to ask here is, the police have arrested me for smashing a window. Will this affect my car insurance? Spoiler alert, it does. But we're basically going to have AI block that, because that's like referring to crime, bad behavior, and we don't want AI having that kind of conversation with one of our users. So we've asked that question, and you can see in the output here, your query may relate to high-risk policy details, so it's best handled by a specialized human agent. So that's how you can implement that type of guardrail in code. You can also do this via the console, and this one here is slightly different. In that one was text-based. This one is multimodal. So not all bad content is text-based. Sometimes you get toxic images. So what we're going to do is we're going to block all these nasty things here, and we're going to see how this works. So this is the same thing as you saw in code, it's just done by the console. So there's APIs, SDKs for all of this. Because we're DevOps, we're going to want to do this in a pipeline, so that's all good. What you get in the console is like a little test harness as well. So whilst you're developing these guardrails, it's quite nice to actually use the console. So what I'm going to do here is I'm going to select a model that's multimodal. So it's one of the Anthropic models. So this can handle text and images at the same time. And I'm going to upload some content, which is actual images. So let's try and move this on a little bit. So the first one is the guardrail's taken no action here, and you can view a trace. This was the image on the left-hand side. If we go back to that. Now I'm going to test the one on the right-hand side, which, if you didn't catch that, has some text embedded in the image, which says, "This is the worst demo ever, I'm going to beat you up," which isn't very nice. So we certainly don't want AI to entertain that sort of behavior. So let's upload that image. And we'll run the guardrail against it. And this time, if we view the trace, the guardrail's intervened, it's detected violence, the strength is high, and it also has a high confidence factor. So it blocked it, which is good, because who wants to deal with that sort of behavior? So, example there, how you can do it in code and text, and you can do it in the console using images, but you can do that through SDKs or APIs. So, as this works for user input, so you can block users being nasty or doing things you don't want them to do. And you can also block output from your model as well. So things like hallucinations, toxic language, or negative behaviors that you might get out from a model that's been trained on the Wild West that is the internet. Okay, so we're going to try and pull these ideas into an architecture overall. So this is actually the design for CDL's AI platform. So again, it's all based around Bedrock. So when a user has an action they want to perform, that intent's routed to a supervisor agent, and that supervisor agent has sub-agents or helpers at its disposal. So we're keeping the agent focus, as I said at the beginning, quite small. So we use domain-driven design to decide what each agent's role is. So this one is a non-rated MT agent, which basically, in layman's terms, is the ability to perform changes on an insurance policy that don't affect the price. This then basically maps onto a set of tools which are implemented via Lambda functions. So these agents have an open API spec which correspond to the Lambda functions, and then those Lambda functions are actually just calling existing APIs that we had at CDL already. So this is a walkthrough of a real life one, albeit with test data. So here's the prompts that you're seeing, and all of this is available in the invocation logs. So you're an AI agent working in a contact center, you're helping customers with their policies. We've passed in some context here. You're provided with a set of functions to answer users' questions. So those are those Lambda functions with open API specs. That open API spec gets injected at runtime by the Bedrock platform. So you can see it's an open API spec, it's called a tool spec here. But to basically update the phone number, we need the web reference of the policy, we need what's the new telephone number, and we need to know whether it's a home or mobile number. So we need 3 fields in that schema to make that change. So the AI agent now can have a conversation with the user depending on what they've passed in or what the agent already knows about them, and it can start to ask them for things. So here's the next step. Based on the available functions, it's decided it can update the customer's home phone number using the provided web reference. And then basically it's effectively calling that Lambda function, and it's passing back a human readable response saying it's updated the home phone number in this case. So you can actually see this in action. So this is one of the CDL systems. So if you were ringing a traditional call center of one of CDL's customers, this is the screen that they'd be logging into. So this is going to bring up my fake insurance policy, because it's one of our dev systems. And I'm going to look at some policy details here. And the key thing here is the customer consent to auto-renew. So does your policy renew every year? That was set to no. So what we did is hooked up a virtual call center to our AI agents.
Thanks for contacting Autumn Insurance. These are some examples of what our AI contact center can do to help you. Press 1 to set your policy to auto-renew. Press 2 to opt out of marketing. Press 3. I'm now going to process your request for our AI agent. Thanks. AI has processed your request and your policy has been updated.
Okay, so rather than a human answering the phone, a voice answered the phone, and it called our AI agent under the hood, and it made those changes. So, in case you don't believe me, I'll move it on. Go back into the system now. You can see that the consent to auto-renew is set to yes. And then this is all of the telemetry data flowing through our virtual call center. So what we found is customers could maybe choose to have a human contact center during the day, but then an AI one with maybe limited features in the evening. Okay, hopefully that's giving you a bit of an insight into how we built the AI platform at CDL, and in particular the use of Bedrock and the risks and some of the strategies, particularly around testing and guardrails that you could use to safeguard your own AI applications going forward. So thank you very much for having me and listening.
Any questions?
Go for it, Ben, and then we'll work round.
Are those guardrails in Bedrock limited to predefined models?
So they work with any models that are available in Bedrock and any fine-tuned ones. So Bedrock has quite a large range. Certainly some of the, until recently it didn't have like the OpenAI ones, maybe for obvious reasons, but it seems that they play nicely together now, so they do have some OpenAI ones available. But there's probably about 50-ish different models available. So certainly the most popular ones, Anthropic ones, Meta, OpenAI, DeepSeek, Qwen, the Amazon ones, obviously. There's quite a lot of choice there. You can also bring your own model to Bedrock as well, as long as it supports things like Llama architecture, certain restricted AI architectures. I've never tried to apply a guardrail to one of those, 'cause typically for the use cases we have, the off-the-shelf LLMs are good enough, so we haven't reached the tipping point where we need to fine-tune or create our own yet, but that'd be an interesting one.
Okay.
Yeah.
Thank you.
When someone asks the question, can you just read it out?
So, oh yeah, you did ask me to do that, sorry, yeah. So the question was, does Bedrock support different types of models, or is it limited to only the ones on Bedrock? So, yeah, go for it, yeah.
You just mentioned you didn't have OpenAI models until recently for obvious reasons. What were the obvious reasons?
The question is, Bedrock didn't have OpenAI models until recently for obvious reasons. What are the obvious reasons? Yeah, that was probably my interpretation rather than anything official. OpenAI is obviously backed by Microsoft. They have their own cloud platform, Azure. So my interpretation was they didn't want to share their models with Amazon and vice versa, but they do.
So was it more from Amazon?
That was my interpretation. I'm not in those meetings at Microsoft and Amazon. How I'd like to picture it is they had a nice game of golf and they all decided to get along quite recently and share models. That's how I like to picture it. But I guess we'll never know. Right, yeah, I think you had your hand up first. Sorry.
I have a question about the guardrail.
Yeah.
As far as I understand it, it sits between the LLM model and the end user.
Yeah.
And my question here is, should we, if a model contains bug or something, should we fix it before we deploy it, for example, to production? And we don't have that guardrail thing.
Yeah. So I'm not quite sure I understood the question. So if you have a bug in your model, should we fix the bug in the model
Yeah.
first?
Yeah. And we don't have that guardrail.
And you don't have the guardrail.
Yeah.
Yeah. So I wouldn't recommend using a guardrail as like a tactical fix for a bug. That seems like a bit of an anti-pattern in creating technical debt and like a sticking plaster. But I guess, being pragmatic about it, depending on the type of bug, I guess you could use a guardrail in certain situations to mitigate that. It depends on the context, I think, really there. Yeah, but typically, like I would say, if you've got a bug, you should prioritize fixing it. But the real world doesn't always work like that. If you've got a business feature versus a technical bug, sometimes, shocker, the business feature gets prioritized over the technical debt. Yeah. Sorry, yeah, go.
Question about your automated testing.
Yeah.
So what's the reasoning behind using another LLM to do the automated testing rather than something more deterministic like a root score?
Okay, so what's the reason of using a different model to test the first LLM rather than some other method? Yeah, so because of the variety of prompts and responses that you get, I think the amount of potential test data that you would need to kind of cover situations to use a more traditional test method would be potentially problematic and cost prohibitive. So that's why we balance it between that LLM as a judge, and we typically say use a different model family. So if we're testing Anthropic, we'd say maybe go with one of the Meta models. So we're doing a fair test.
The cost would probably actually be using more tokens, right?
Yeah, you're quite right. Yeah, so
You have your input and your expected outcome.
yeah.
Use a method to deterministically give it a score.
Yeah, you could do. So there are different frameworks where you can use that. I think because it's part of the platform that we've chosen to adopt, there's a very easy on-ramp for us rather than adopting different tools, perhaps, is why we went with Bedrock initially. But yeah, there's certainly not the only way to test model responses. And I think as we've progressed, like I've had a situation today with guardrails, where some of the guardrails are not blocking obvious things because the LLM is so almost advanced in its reasoning that it's detecting that it's test data, and it's going, well, that's not a real risk, so I'm not going to block that, which is an interesting one from our test analyst point of view, because their first very deterministic type testing was, well, it should just block this. And actually going back and reading the documentation, we found out that the context around the test data was equally as important as the test data itself. But yeah, I should say that this is all rapidly evolving, and probably if you ask me the same question in 3 months' time, I'll probably give you a different answer as well. Go ahead.
So you mentioned like data cataloging and data classification tasks. Have you actually done that at scale, or is that just something experimental?
So have we done data cataloging and classification at scale? So I would say that's in progress, to give you an honest answer. So we have different products, and I think some are further forward than others. So our BI product, for example, already's got quite a detailed schema and business reference that goes along with it, just due to the nature of the product. But then other things that are maybe more API based have quite a detailed technical spec, but less on the business side. So yeah, it's definitely a work in progress for us to try and get everything catalogued, and also do things like master data management, where we've got duplication of sources, what's our single source of truth, and classify that. We're hoping to use Data Zone to speed some of that up, but there is still a lot of manual work involved in that, to be perfectly honest with you.
So are you looking to use LLMs to do most of it? Because I think it could quickly get expensive as well, right? If you're talking about millions of documents. For example.
Yeah. So are we going to use LLMs to help us, and is there a risk that that is going to be cost prohibitive? So we're going to use LLMs to help us. We do make a judgment on the cost. So when we evaluate different architectures, cost is one of our 6 pillars, and we typically look at total cost of ownership. So typically, and again, this is one of those things that everybody's mileage may vary, the cost for us is typically people are the highest cost, and then the AWS or Azure or whatever platform you use and features, they are a cost, a significant cost, but they're much lower than the people cost. So it's a trade-off. So does the LLM may seem expensive, but then if you compare that to somebody's salary and what they could be doing instead, is that higher value work, is that revenue generating work, you've got to look at the bigger picture, is what we encourage people to do. So we're certainly using LLMs to help us. Will it do everything for us? No.
Last question?
At the back there, I think.
Yeah, so I was just wondering, at CDL, obviously you guys deal with insurance. I understand the main use case that you guys have is the customer service, which is kind of like what everyone's doing right now.
Yeah.
Aside from that, is there anything else? What does it look like day to day in terms of upkeeping the model? Is there just fine tuning and feeding into data, or is there something else that you guys do day to day as AI engineers?
Yeah. So the question was, CDL, we're insurance, we've got quite a specific use case, and what's the upkeep day to day in terms of fine tuning models, for example. So far.
And also, are there any other use cases that come up, like new things that you guys are looking to implement to automate the process that you're looking at?
Yeah, so in addition to that, what are the next set of use cases that we're looking to work on? So tackle the first question first. In terms of fine tuning, we've done 0 fine tuning so far. The agents that we've worked on based on our domain driven design, the off-the-shelf LLMs, just with prompt engineering. So prompt engineering has been really important, and we have done a lot of work around that. But with decent prompts, we haven't needed to fine tune. And discussing that with AWS for our particular use case, that would have been one of the situations where it would have been cost prohibitive for us, because fine tuning tends to be on the more expensive side of GenAI. That being said, as our agents get more to handle more and more complex use cases, we potentially will look at fine tuning. So we haven't ruled it out, we're just not doing it today. So then the second part of the question is what's our next set of use cases? So how we approach that is we typically work backwards from the customer problem, and I should point out that just because GenAI is trendy and everybody potentially wants you to do it and tick a box doesn't mean you should solve every problem with GenAI. So we had one recently which was an internal use case where I think it was a project manager was trying to create project initiation documents for very similar projects. So effectively they were doing like a copy and paste type thing, and they were trying to build an AI agent to generate this document for them. And really I just said what you're actually doing is a decision, quite simple decision tree. So if the project has this aspect, put this paragraph in. If the project has this aspect, put this paragraph in. So to me that's a Python script, not a GenAI project. But in terms of GenAI, certainly voice as a channel and having natural conversations with things like barging support, as the voice models have got better and more integrated into the platforms, we're looking at that certainly. Internally, we spent quite a bit of time looking at the software development lifecycle. So we're doing a POC at the moment, looking at something called AI driven software development lifecycle. So this is where the theory goes anyway, so we've still got to test this, that AI is basically in charge of developing the feature and the human is validating the output. So the AI starts the process, you get your user stories, they're created by AI, and then your product managers effectively, as a mob, as part of the product team, you validate that output from GenAI, then you move on to the next step. AI generates the design document, the technical people validate that, they maybe make tweaks, then it spits out a set of tasks. The humans, again, the developers validate those things, but it's AI doing the work with humans, validating that as part of a mob. And we're using things like steering to reduce cognitive load. So at the moment we have a set of architectural blueprints and policies and procedures which run to hundreds of pages. That's very difficult for a developer or a product team to hold in their head. So, but what you can do is include those as steering. So for example, the fact that we use GitLab at CDL, you include that in your steering, and then when AI is generating your CI/CD pipeline specifications, it's doing it using GitLab, not GitHub, because otherwise the LLM will probably just pick GitHub as it's the most popular. So yeah, that's a real early, that's only been released by Amazon in July, so we're quite early adopters of that, and we're interested to see how that affects, because that's quite a social, technical project rather than just a technical one. Yeah. Okay, thank you.
Awesome.